All right, so what should we look at? We got to look at maybe should we look at a U substitution problem that involves limits of integration?
Sure.
Okay. And then maybe we'll look at a trapezoidal rule problem. How's that sound? Okay, so let's try. How about oh, I like this one. This is good. Whew. This'll give us lots of practice on many important things. This is good. So we've got x times cube root of x plus 1 dx from 0 to 7. Okay? All right. Put that away. That nonsense away.
What are you here, Brett?
Come
on, you gotta catch up.
So what do we got? How are you going to come up with more kinds of arcane Star Wars strategies if you can't do calculus? Answer, it's impossible.
Yeah.
There we go.
Come on.
Okay, so arcane interpretations of Star Wars. The next, you've already used up all the algebra-based ones. Now it's time for some calculus-based
Yes, I have.
interpretations, all right? So you got to get on to the next level. So what do we got here?
Make a U. X plus
Make a U.
1 equals U.
Good. And what's our, it's not like there's some, this is getting to be, calculus is more of an art. I mean, it's not like it used to be where there's just, you just kind of plug and check. You got to think about this. What's a logical U? Well, the logical U would be the argument of that cube root function, right?
So it's not x to the third, it's the cube.
It'd be, that's a cube root. It's supposed to be a cube root, right? Okay. So then our choice would be U equals x plus 1. So what's du?
Du is
X, or 1.
squared. Wait.
1. Just 1. The derivative of U would just be 1.
No. I didn't ask you what du dx was. I asked you what du
Oh.
It
was.
would be
Oh,
x squared.
1 plus dx.
No.
1 plus dx. Dx. 1 times dx.
Right? Because we're writing it, okay, what's the distinction? Well, this is a derivative in differential form, right? You could, if you wanted to, I wouldn't recommend it, but you could say, what is u prime? Du dx equals 1. So if du dx equals 1, then du equals dx, right? But the way that we kind of think about this is, if u equals x plus 1, if I'm just differentiating both sides, well, the derivative of u is du, the derivative of x is just dx, and the derivative of 1 is 0, right? What if that had been x squared? Then we would have had 2x dx, right? Okay, now why do we do that? Well, because we want to be able to determine what have we substituted for. This becomes a u, that's taken care of, and dx equals du, right? So when we make our substitution then, we've got the integral of, what have we accounted for? Well, we got a cube root of u, so we could write that as u to the 1/3 times du, but still got that x stuck there, right? And my limits of integration, really what this is implying here, we don't write it, but technically that's saying x goes from 0 to 7, right? Okay, so then I'm trying to transition into an integral involving u's instead of x's. So remember what the shortcut is here. We could take the long road, but we're not going to, where we could keep our limits in terms of x, find the antiderivative for u, and then convert back to x's to evaluate the limits. Much easier, though, would be to do what?
Like the x to U.
Yeah, we're going to convert our limits of integration from x's into u's, so we don't even have to go back. Because remember, this is a definite integral. Our answer is just a number, right? It's an area. So then this is going to become what? When x is 0,
U is 1.
u is 1. Sounds like I'm using bad grammar. when x is 7, u is 8. Okay? But what I still have to do, there's something else going on here. Okay, good. I've got to complete the substitution, right? It's an incomplete substitution. That's the language we'd use in math. So I must complete the substitution. So what is x in terms of u? Okay, so right? And so we end up getting then the integral of the quantity u minus 1 times u to the 1/3 du as u goes from 1 to 8, right? So what do we do there? Got to distribute, right? So we get the integral of what? U to the 4/3 minus u to the 1/3 du. And what's the answer to we're just going to integrate term by term, right? So the first one's going to give us what?
So we're putting x back?
No. We're going to take the integral though.
Oh.
We're going to find the antiderivative, right?
Would it be 8? Start with 8?
We can't do any of that stuff yet, right? Remember this goes back to first fundamental theorem of calculus. We've got to figure out what the antiderivative is, and then we'll evaluate it over the limits. But we haven't done the calculus yet.
So, what did
Kylie always gets these. What's this one going to be? You're quick with these. So if what's the antiderivative of u to the 4/3?
It would be u to the 7/3 times by 3 divided by 4.
3/7,
3/7.
Right.
3/7.
right? So we're going to get 3/7 u to the 7/3, right? Minus, what's the antiderivative of u to the 1/3?
3/4 u to the 4/3.
There you go. 3/4 u to the 4/3, all evaluated from 1 to 8, right? So here, you get a choice here. You could either do each part individually from 1 to 8, or you could do the whole thing, right? Doesn't make it, same answer either way. Makes no difference. So what do we get if how about if we just do the whole thing? So we're gonna get, actually, let's not, because then we can pull the 3/7 out. So let's write this as, not that it's a huge deal, but see how that might be just a little bit easier, right? See what I'm saying? So then we end up with, well, what's 8 to the 7/3? What's 8 to the 1/3? 2. What's 2 to the 6th?
64.
64. So 2 to the 7th must be
128.
128. There you go.
I didn't do that.
And then 1 to any power is
1.
1. So u to the 4/3 must be what? I mean, 8 to the 4/3, sorry.
2, 16.
16, right? Make sense? Because, u cubed is, u to the cube root of cube root of 8, I can't talk, is 2. 2 to the 4th is 16, right? Everybody, we good with that? I rushed through it, but I think you guys are fine. Okay, so then we would just simplify that and get what? So I'm gonna get 3/7 times 127, right? So I'm gonna get 3 times 7 over, or 127, sorry. Minus, no, never mind, I already did that. Minus 15 times 3 over 4, right? Everybody agree? And let's see, 7's not gonna go into 127, no. So that's just gonna be some big number. I don't wanna do the big number, but it's just some big number, you guys can do it. That's,
Would it be 321?
for this one would be,
No, it would be 380.
Not 21, 381.
yeah, 381 sevenths minus 45 fourths, which, I don't wanna do that. We have to get a common denominator of multiply by 4 over 4 and 7 over 7, but you guys can do that. That's, I've already done enough of that. I've paid my dues. Okay,
Did I do watch or something?
so we got that, no big deal.
That wasn't calculus though, it was just boring math.
Yeah, this is boring math, right, exactly. That's, I just call that's just some hand waving. You guys can do that
So
stuff.
that's the steps on which calculus is built.
Exactly.
Which means we don't need to go over.
Or no. Okay,
I think that was good.
Yeah.
Piece of cheese.
okay, you wanna go through a trapezoidal rule one?
Oh, yes.
Okay.
You're recording, right?
I am recording, yes I am. Okay, so- Alright, so trapezoidal rule, what would be a good one to do? Something like,
You hear the teacher keeps going on the recordings.
Probably.
it's so annoying.
We watch you, if she watches them, she's getting trash on her all the time.
Good. Let's take that, teacher.
Okay, so here's a couple that might be worth looking at here. So we could do something like this. Did we do, I can't remember, if we did this one, then let's not. But if we didn't, let's.
Okay.
'Cause I can pick a different one if we did.
Whoa.
What's that doing? Okay, so let's find here. Okay, find n. Okay, so we're gonna find the value of n for that given, 4 zeros, yeah, for that given tolerance. And then let's actually calculate what the resulting area would be to that tolerance, okay? And here's the function. So we're trying to estimate the area under the curve 1 over 1 plus x from 0 to 1, okay? What part do we have to do first? Well, yeah, we're going to have to do a U. But before we can do any of that stuff, we've got to find out what the value of n is, right? So we have to use that error approximation formula for the trapezoidal rule, which is, remember, we talked about that the other day, so that's,
Do we have to memorize this one?
I would memorize it. So the trapezoidal rule is the error is going to be, the maximum error is going to be b minus a cubed over 12n squared times, that is it, isn't it? Times, yeah, times the maximum value of, let's write that a little differently. They write the absolute value bars. Remember, this was the weird part. It's the maximum of the absolute value of the second derivative function on our interval from a to b, okay? And so this isn't hard, but we've just got to go through and do a little bit of analysis, right? So first thing we got to do is we got to know what is the second derivative, right? So if our function, if f of x, wasn't it 1 over 1 plus x, what's the first derivative? How would I treat that?
So,
Make it x to the negative 1.
It'd be 1 plus x quantity to the negative 1, right? Because we have a constant on top when we differentiate. We don't want to use quotient. So that's going to equal negative 2 times 1 plus x to the negative 2. Everybody agree? And then the derivative of 1 plus x is just 1. Right? We good with that? Okay. Second derivative then would just be positive 4, 1 plus x to the minus 3, which is going to be 4 over 1 plus x cubed, right? Everybody agree? Okay. So then what's going to be the maximum amplitude of this thing? Well, let's just think about this. If a is going from 0 to 1, right? Everybody agree? What's going to make this fraction the biggest?
0.
0 is, isn't it? Because we want the bottom to be as small as possible, right? So then I'm going to do this like if I were doing this on a test, like a college test, I would have said something like f double prime of x is maximum on, oops, 0 to 1 when x equals 0, right? So what's that equal to then? 4, right? Okay, everybody agree? Okay. So then all we got to do is now just some algebra, right? So we'll go back up here. B is 1, A is 0, we're solving for n, right? And they told us that our tolerance was 0.4 zeros and a 1, right? So then this equation is just going to become 1 minus 0 cubed over 12n squared times 4 is less than or equal to f, right? If I'm solving for n, this just becomes, doesn't this just become 1 over 3n squared, right? So 3n squared has to be greater than or equal to the reciprocal of that. So what's that going to be? 1, 2, 3, 4, 5, right? That's 10 to the minus 5. Okay, everybody agree that's going to be a minus 100,000th, right? We've got 10th, 100th, 1000th, 10,000th, 100,000th, right? And if I want to, I could even just leave it as 1 over that decimal. I'm just going to put it in the calculator anyway. Or I could write it as 10 or 100,000. For this, just for this case, what if that were a really long string of zeros? Let's just write it as 1 over 0.00001. That's fine. What am I going to do? Well, I'm going to divide both sides by 3, which is going to give me the inequality. Let's go down here. It's going to give me the inequality n squared is greater than or equal to 1 over. If I multiply this by 1/3, what am I going to get on the bottom?
0.0000.
Yeah, good. 1 over 0.00003. I can just leave it like that, and I'm just going to square root both sides, right? So I'm going to get n is greater than or equal to okay, so what we get? Square root, sorry. Square root 1 divided by 0.12343. Okay? And that is about 182.57. So what's that mean?
That's what n is, or that's what it has to be. So that's greater than.
So what's n equal?
Something less than that. So like
Greater than.
182.
So what's it gonna be?
Oh, 183.
183. Would be the smallest value we could pick, right? Okay, so then if we wanted to, now that we've done that, now that we know what n is, well, now we can go up and do the trapezoidal rule, right? Apply the trapezoidal rule in this for an approximation. Okay, so remind me then, and this is an easier one to remember, what is the trapezoidal rule? What's it equal to?
B1 plus B2.
It's,
Wait,
It's
the area of the trapezoid, right?
well, no, but what's the trapezoidal rule for approximating area, right? It's just gonna be b minus a, instead of b minus a over n, we've got that extra 1/2 out front, right? So it's b minus a over 2n times what? F of a plus f of b plus 2 times the interior sum. Remember this? Because remember we double counted all the interior endpoints. 2 times the interior sum of f of a plus I delta x as I goes from 1 to n. Jonathan remembers.
Trying to remember.
It's the interior sum, right? This is really x of 0, right? And this is x sub n.
That's one.
So it's n minus 1, right? We're only adding up the interior ones. Remember that?
Wait.
1, 2, n minus 1. And in the book, they write it a couple different ways. They also write it as, I'll pull it up in a second, and we can just remind ourselves, what. Sometimes you don't, if n is really small, you don't even need to write it that way. But n's big here, right? So we're definitely going to write it in terms of a sigma, because we want to let the calculator add that up. I don't think you want to add up whatever it was, 138 terms or something crazy like that, right? So what does this become for us? Right, we're doing the integral of 1 over 1 plus x from 0 to 1. So what's that tell us? What's a, what's b?
1 minus a, so it's just 1.
1 minus.
So
Over 2
0, a is 0, b is 1, right? N is equal to, so n is equal to delta x, I guess you could say. Delta x is b minus a over n, right? So that's equal to 1 over, what was n again?
183.
What was it again? It was
183.
283? No, 183, okay.
183.
Okay, so there's delta x, right? Okay, so then ours is gonna look like, what then? So it's gonna be approximately 1 over 3, what is it gonna be, 366? Right, 2 times n, times the value of our function at a. What's the value at 0? It's just 1. Value at 1 is 1/2, right? Plus 2 times the sum of this, f of 0 plus I times delta x. So it's just f of I over 183, right? So doesn't that just look like 1 over 1 plus I over, that's an I, 183? Right, everybody agree? Okay, from 1 to what? 182. Right? And now we just throw that in our calculator. Does that make sense? Questions on that? Okay. This part should come a little more easily to you because we did all that work on discrete sums. And that's the only reason I do this stuff on discrete sums, honestly, is just so, because you have to do some of this stuff anyway later. But it's just not as hard. Because for us now, we don't have to worry about writing areas of rectangles. All we got to do is just be able to interpret what is f of, really all this is f of x sub I, right? From 1 to n minus 1, right? X sub I is just gonna be a plus I delta x, right? And so if we throw that in our calculator, what do we get? Sounds kind of violent, throw it in our calculator. Well, I guess we're violent. So that's gonna give us, River, I'll go ahead and use that template for you, how's that? So we got 1 over 366 times the quantity, 1 plus, can we just call that 3 halves, plus 1.5, how about that? 1.5 plus 2 times,
That's optimization.
yes, there we go. Math 0, I think it is. The sum of what? Well, our variable is going to be x. Our index variable is x goes from 1 to 182 of
Like,
1 divided by 1 plus, ooh, look at this, fraction within a fraction, are you kidding me?
see how nice that looks?
Looks pretty good.
Right? I should keep track of things.
Or here, the times looks like a plus.
Yeah, it's a little out of focus too, I think. So,
We should spend tomorrow
I need
trying
to close
get that.
up another set of parentheses, I believe, don't I here?
Yes, you
Very nice.
So there we go. I think we're good,
do.
right?
Solid.
Yep, press
Okay.
enter. Oh no, you broke it.
Oh, it's working. It is gonna take a while though. A little, it might melt.
Start packing up.
Always.
22 minutes later.
Never seen it take this long.
Yeah.
Could you do that by hand?
Take a while.
Eventually.
Yeah. It would be tough, but you could.
Hey!
There it is. All right. So, and we want it out to 5 places, right? Rounding to the nearest 100,000, so we get 0.69315,
Woo!
right? Would be the correct answer. Okay. Let me just.
Question.
Yes.
What kind of tests, parentheses, are there gonna be? Is there gonna be more than one test?
Yeah, I think I'll do a.
Hey!
Well, yeah. Here's why there will. There's going to be the calculator part is going to be the trapezoidal part because you have to have a calculator to do trapezoidal, right? And the non-calculator part will be the use substitution part.
Just a cool thing. Or
Yeah,
kind of thing.
I mean,
It just makes it easier, you know, because then there's only one test for you to make.
yeah, you
Mhm.
don't have to worry about it.
Yeah, I'll persevere.
You'll persevere. Well, it's good that you're persevering.
So,
Determination.
all right. So now you can use the rest of the time to work.